Hello everyone. In this video, we'll walk you through building a retrieval augmented generation pipeline using Moorcheh and LlamaIndex, focused on legal documents, specifically Canadian copyright law. We'll show how to upload legal texts, semantically index them, and run queries to generate insightful, well-structured answers. This demo uses the Moorcheh vector store, which is now officially integrated into the LlamaIndex framework. You can find the full source code for this demo on the LlamaIndex GitHub page. Before we jump into the code, let's take a quick look at the Moorcheh website to understand why it's such a powerful choice for building RAG pipelines. What sets Moorcheh apart is its accessibility. Embedding, storing, and retrieving documents and generating answers are all handled through a single API. On my screen, you can see the Moorcheh console where you can upload documents, create namespaces, and start running semantic queries instantly. You can also explore more tools and documentation directly on the Moorcheh.ai website. The key takeaway is this: with Moorcheh, RAG becomes incredibly streamlined. Upload your documents, they're embedded and indexed automatically, and then query them using one unified SDK. So whether you're a legal researcher, student, or technologist, this pipeline shows how semantic search can support legal reasoning, education, and interpretation at scale. Without further ado, let's get started.
So all of our code used in this demo is available on the GitHub's example page under the legal rag folder, as shown here. All right, so we'll be using LlamaIndex for document indexing and query orchestration. I'll be using Moorcheh as the vector store, and we'll be using legal text from the Canadian government sources, such as the Copyright Act. So to begin, let's go look at the Colab. So we've copied all of our code into this Colab for readability. First, we're going to install all of the necessary packages, as shown here. Next, we're going to import all of the necessary packages that we'll be using in this RAG pipeline. And then we're going to set up our logging. This is just for debugging purposes. Next, we're going to get our Moorcheh API key, and we're going to set this in the secret variables in the Colab. And on your IDE, this will be set in environment variables. We're also going to create the embedding model, and this will be a local embedding model using Hugging Face embeddings. And we'll also be setting our namespace name, our documents folder, which is the file path for the folder that holds all of our necessary documents, the query CSV path, which holds the query CSV file, which has all of our queries, and the output CSV path. And this will be the file that's created that holds all of our answers. We also set the top K to be equal to 5, and this will essentially make the system return the top 5 most relevant chunks from the document to answer each of our queries. So now let's take a closer look at some of these documents. So first we have our documents, and we'll be using the C-42 Copyright Act from the Government of Canada. And essentially it's a very informationally dense document with a lot of wordiness and kind of a lot of information that needs to be sifted through. But using Moorcheh, we'll try to make this easier and return only the relevant chunks to answer our queries about copyright law. Next, we'll take a look at our queries.csv file. And essentially, this is just a CSV file that holds all of our queries that we'll be asking Moorcheh and hopefully getting an answer from them. Next, we're going to prepare and chunk the documents. So we're going to use Simple Directory Reader to read the documents. And we're also going to remove all of the unnecessary characters or unreadable text from the document to make it more readable for the system. We're also going to set the chunk size to 1024 characters and chunk overlap to 20 characters, but feel free to change this to your required specifications. So now we're going to upload the document chunks into our vector store. And so we're going to be creating our vector store with our Moorcheh API key, the namespace name, and we're going to set the namespace type to text. But you can set it to vector if you would like to upload vector embeddings rather than text documents. And we've also set the vector dimension to none because we are uploading a text-based namespace. But you'll set this to whatever vector dimension you would like if you're uploading vectors. We've also set add sparse vector to false because we will not be using LlamaIndex sparse vector embeddings, and we're setting the batch size to 100. And finally, we're going to create the storage context and the index, and with the index, we'll be using our local embedding model.
Now we can move on to the generate answer method. So in this method, we're going to read our queries. So taking a look at our queries.csv file, we designed our queries across three tiers. The basic tier involves asking questions like what is copyright law and why does it exist? Or how long does copyright in sound record lasting in Canada? We ask harder questions like what constitutes copyright infringement under Canadian law, and then we ask advanced reasoning questions such as if a moral right is violated but not the economic right, what legal actions are possible? As you can see, these layers of questions involve deep synthesis and multi paragraph understanding. We ran this queries using Moorcheh's semantic answer generation using the get generated answer method. We went through each query and through the AI model from Moorcheh's SDK, we used Claude 3.7, and then we generated the answers from them. These answers were displayed in the answers.csv file. As you can see, it has a passage ID, a query, and the generated answer from it for each of the following questions. Looking at specific questions, we found that the RAG pipeline consistently returned context-rich legal information that aligned closely with the source documents. So, for example, when we asked about the duration of copyright in sound recordings, the system accurately identified the specific timelines. And even for more specific or edge case questions, like what legal remedies are available when only moral rights are violated, the pipeline cited specific provisions like Section 34.2 with clarity and precision. So this shows that it's a really well-designed RAG pipeline, and Moorcheh can significantly return accurate answers.
So you'll notice with this RAG pipeline that we've only ever used one API key. And as shown here, we're only using the Moorcheh API key. And this kind of is in line with the RAG in one call that we have with Moorcheh, where you only need the Moorcheh API key to run all of your semantic search questions and answers. And this makes Moorcheh kind of a unique vector database to use over the other vector databases in the market, and it makes it sort of easier to use and kind of, with only needing one API key, it makes it a lot more user-friendly. So with this demo, we hope that we've illustrated how combining Moorcheh and LlamaIndex enables robust semantic legal search across dense law texts. So whether you're building tools for lawyers, automating compliance checks, or exploring AI in public policy, you can use Moorcheh to interpret and provide legal knowledge. So we'd like to thank you for watching our demo, and be sure to check out the code on the GitHub if you would like to build your own legal RAG pipelines. Thank you.